So we will continue our discussion on horizontal curves, and first we'll discuss a simple circular curve. So now let's discuss a few notations that are usually used with not just simple circular curve, but you'll see in due time with other curves as well, because they are just extensions of simple circular curves. So over here we have a very basic diagram of a simple circular curve. So as we have discussed before as well, so we have the point A and the point B, which is the initial direction of the road, and the point B and the point C, which is the final direction of the road. And we need to join these two lines with a curve, and the curve starts over here at the point T1 and it ends over here at the point T2. Now, if you think about it, uh, these are this is a complete circle. Now, if you see this line AB, so this is basically tangent to the circle at the point T1, which is the starting point of the curve. Similarly, over here, the point T2, that is a tangent point for the line BC, which intersects or which is tangent to the circle at the point T2, which is the ending point of the curve. So after T2, the road becomes a straight line, and before T1, it is a straight line. And between T1 T2, you have arc of a circle. And the two points are then joined to the center of the circle O, and the lengths of the lines become the radius, and you have a arc of a circle or a curve. So in this, let's see the point number one. A, B, and BC are known as tangents to the curve, like we have discussed. The point B is known as the point of intersection or vertex. So we're looking at it from the plan view, and the point B is the topmost point. So that is why it's called as the vertex or the point of intersection. Um, the angle phi is known as the angle of deflection. So this is the direction of the roads initially, and this becomes the direction of the road afterwards. And this angle over here is called as the deflection angle. So more the value of the deflection angle you can see, the more steep would be the curvature. You would need to give a curve which is very steeper, or if you are imagine you're traveling on the road, so the more closed this becomes, that means you'll have to take a very sharp turn, and smaller the value, that means the curve or the turn wouldn't be that sharp. So that angle phi is known as the angle of deflection, and the angle I is known as the angle of intersection. So usually when you design a curve, you're usually given with either the value of intersection angle, angle of deflection, or you are given the angle of intersection. But by either one, you can calculate the other one. You just subtract the value from 180 and you get the other angle. So the points T1 and T2 are known as the tangent points, like we have discussed. The distances BT1 and BT2 are known as tangent lengths. So this distance, this is equal to BT1, and this distance, this is equal to BT2, and these are known as tangent lengths. So when the curve deflects to the right, it is called as a right hand curve. When it deflects to the left, it's known as the left hand curve. It doesn't really matter. It's just observation point where you're standing. So you can neglect this point. It doesn't have that much value. AB is called as the rear tangent and BC is the forward tangent. Again, you don't have to go into that because usually the curves are two-way and it can be either one. The straight line T1, D, T2 is known as a long chord. Now this is important. So on this curve, what is your direction of travel? So your direction of travel is A, T1, along the curve T2, and then C. Now this is your direction of travel. T1 and T2 are the tangent points where the curve actually starts. Now, if you join these 2 points with a straight line, so T1, D, T2, this line is called as the long chord, right? And remember when we derived the expression, the relation between radius and the degree of the curve. So over there, we also saw what a chord is. So over here, that line or that distance is called as the long chord. So in actual, you don't travel on this line, but again, what we are doing is we are trying to find out different things because they would help you in setting out the curve in the field and also in designing the whole thing. And the curved line T1E T2, so T1E T2, this is called as the length of the curve. So this is actually what you travel on. Hence, this is called as length of the curve. The midpoint E of the curve, T1E T2, is known as the apex or summit of the curve. So again, if you look at it from the plan view, on the actual line of travel, the topmost point or the point with the highest distance from some reference is the point E. And that point E is known as apex or summit of the curve. Before we discussed the vertex of the curve, which was the point B. But remember that point B is there when you are trying to lay out the curve in the field up till the construction. Afterwards, that's gone. There is no center of circle, there's no point B. You just have A, T1, E, T2, and C. So in that sense, B is the vertex and E is the apex or summit of the curve. Summit or apex mean the highest point. The distance BE is known as the apex distance or external distance. So this distance BE is called as apex or external distance. And the distance DE is known as worst sine of curve. So this distance DE is called as the worst sine of curve. R is the radius of curve as discussed. The angle T1O T2 is known as is equal to the value of the deflection angle. So this phi is equal to at the angle at the center of the circle. And you draw the two lines joining the 2 points, the radius, and that value of the angle is called as the deflection angle. And the point T1 is known as the beginning point of the curve, and T2 is known as the point of tangency or the end point of the curve. So just a few definitions that you need to keep in mind before we move on to design. So now let's discuss properties of the simple circular curve. So the first is the angle of intersection is given, or if you're given with the angle of deflection, you can find out the other one using the same simple relation where you subtract it from 180 degrees. Second, if the radius is not given and you're giving the degree, then by using the relation between radius and degree, you can find the other one. So usually when you work with curves or you design the curve, you are usually given with either radius or degree, and you're given with either angle of deflection or angle of intersection. And then by using these two, you can design the entire curve. The tangent length BT1 and or BT2 is equal to R tan phi by 2. So if you see this diagram over here, what is the tangent lengths? So we discussed the tangent lengths are BT1 or BT2, and we need to find a relation by which we can find these out. So since this is the deflection angle phi, and if you see this triangle BT1 T2, this triangle, now you know that the exterior angle of a triangle is equal to the sum of two opposite interior angles. So this phi would be the exterior angle, and this is equal to the two opposite interior angles. And since it's a symmetric sort of triangle, so this angle becomes phi by 2, and this angle also